Welcome back, everyone. After the Pilot TV37 got put together, I was left still wanting a little more. I really wanted to get the IF alignment done, but I still don't have a generator that is capable of producing the frequencies necessary to actually align it, at least not one that works. I have two units that are capable of it, and today we're going to look at one that I do want to use because it's a little more user-friendly, and it's also useful for regular AM radio alignments, and I want to see how accurate it is. So this is a precision apparatus E-200-C signal generator. The original E-200 came out in 1939. The C variant came out around 1947 from what I've been able to look up. And there were some changes aesthetically and internally. The earlier sets use octal tubes. The later sets that were made apparently all the way up into the 60s started using miniatures. But there's only 3 tubes in this thing. It's a pretty straightforward setup, and I just want to go through it and get it working, and then check the accuracy, because Precision claims that this should have a 1% accuracy between what's on the dial and what's actually coming out of the jacks on front. And there were a few features of this that I was a little curious about, like why are there 2 RF controls on the front? And what's the deal with having an automatic volume control setup on here? So I thought it'd be fun to just go over this, get it working, see how accurate it is, and then I can... I actually need to use it to try and finish up an alignment on an Atwater-Kent radio that's giving me some grief. But to start with, the easiest thing to look at is the features. So like most RF generators, there's actually 2 sections. We have the actual variable frequency oscillator, which lives on this side of the chassis, and then on the other side here, separated by a piece of metal, there's a power supply and the modulated tone source. So there's a 400 hertz audio modulator oscillator in there. So the actual VFO is handled by a 6SJ7 on this unit. The power supply is going to be either an 80 on the early ones or a 5Y3, which is the same tube with an octal socket. And then the oscillator is handled, or the tone oscillator is handled by a 6C5. Some folks have found 6J5s popped in there because they're both triodes, same pin out. I believe the 6C5 has higher gain. I'll have to double check a book to really be sure about that. But as far as controls, we've got a typical band selector. So top half up here, A, B, and C is for everything in the kilohertz range. Got E, F, and F2 through F4 here. So this is the band that I'm interested in. And we have 2 RF controls, 1 and 2. We've got an RF low output and an RF high output. We've got a modulation control, and we've got the automatic frequency business over here, as well as the modulation switch. So on the left side, make sure I'm actually near this. On the left side anyway, these are really curious because I was under the impression initially that each one of these was tied to one of these jacks, because this is the RF output using the Switchcraft microphone style deals. I like leaving these in place because I can buy these connectors, and if I have to make an adapter I will. I don't like swapping them out for B and C because that's just one more thing I got to do, and I like leaving it as original as I can, bar the necessary components to make it serviceable. And plus then I'd have to replace this cute little cap they included. Anyway. These 2 RF potentiometers are actually tied back to back. So it seems that the signal comes in, it goes in through the center tap of one of these. The one side of the potentiometer is connected directly to ground, and the side opposite that is connected to the top of this potentiometer. And then this one's center tap is the actual output, or it goes into RF1, then goes into RF2, and then comes out. It's a curious arrangement. I'll need to print off a copy of the schematic to make that a little more apparent. And then the output from RF2 comes out to these 2 jacks. Now, it comes directly out to the high jack. The low jack and the high jack are actually coupled together with a 4,000 ohm resistor. That's the only difference between the 2. I thought it was interesting. I'm assuming this is just a means of getting really fine control. Instead of having one potentiometer with a really high value that... You wouldn't have I can see why they did this, because they want a little bit more granularity. If you had one pot with a really high value, you're adjusting the value in large increments. Whereas with this, you actually get quite a bit of adjustment. Now, I didn't double check to see if these are the same size, like they're both 10,000 ohms or one's 10, 120 or something. Ultimately, it doesn't really matter. Probably set one to maximum and then just twiddle the other one, but it gives you a little more freedom of control over how strong you want the output signal to be, so that you don't get the radio or whatever it is under test, you don't overdrive it. So again, we have our band selector switch. Got the actual dial here. I like the design of the dial, although there are washers under each of these screws here that separate the plastic from the actual aluminum. Someone took the washers out of this side, so it was actually crushing the plastic against here. I need to fix that. And also they put the price tag when I bought it directly over the dial, so I got to use some goo gun to get that off of there. Right, so on the right side, got the modulation control. That's so if we want to use an external input for modulation, suppose you could use a separate carrier wave and then actually have do some funny stuff with it, or just generally you could input your own audio source. Technically you could use it as an AM transmitter. Most generators like this will have an external input. The fancier ones will. Some of the smaller ones will only have a fixed 400 hertz audio tone. So on this, we do actually have input jacks here. They're either input or output, I can't quite remember. But we have our options of just having an output of unmodulated radio frequency signal, so you're just getting a pure sine wave. Modulated RF, so whatever you're combining it with, which in this case would be the 400 hertz audio tone, so we have an AM carrier wave with a sound applied to it. External modulation, so I plug something in, we can fiddle with it if you want to plug in music or something. And then interestingly, it looks like if you flip it to 400 hertz audio, you skip the VFO entirely and it just outputs a 400 hertz test tone, which could be useful if you just want to pass something through the detector stage, make sure the audio amp is working. Now, one of the more interesting features that apparently Precision played up was this little guy. So the actual power switch is coupled with this automatic volume control pot here and these jacks. The idea with this is that we have a variable negative power supply that is supposed to be connected to the automatic volume control bus inside a radio or whatever you're working on. And then you can adjust it so that the AVC voltage in the set is constant, because the AVC is going to be adjusting the gain in the IF stages. And that's so that radio signals, the volume is effectively equal. Whenever you switch from one to the other, you don't get your ears blown out by going from a weak station to a strong station. The AVC will actually clamp down the signal level by lowering the gain in the IF stage. Well, it applies a negative bias to the grids. The problem is that if we input a signal, sometimes the IF, the gain will go to absolute maximum, and it could. They're assuming that it could screw up the alignment if the AVC is allowed to do whatever it wants. So the idea is you would hook this up to the AVC and basically hold it at a fixed level so that it's not interfering with the AM alignment. I do occasionally see this being used necessary in TV alignments. In some cases, they do actually specify you need to apply a 1.5 volt, 2 volt, 3 volt bias to some part of the IF strip in order to properly align it. With radios, some people question the necessity of this when doing that. I've never had a reason to do it. Whenever I align a set, I haven't found had any issues with the AVC being particularly troublesome, because most of the time I'm careful not to just crank the RF output to absolute max, which would cause the AVC action to go into full power in order to try to pull it down to a nominal level. So I try to be gentle with that. So I'm probably not going to use this. We'll see if it still works afterwards though. But let's flip it around and see what we actually need to do to get this thing working. There's not all that much here, and it's fairly cleanly laid out. So on the left back here, this is the power supply and audio section. On the early ones, we have an multi-section electrolytic here. This is 3 sections, according to the schematic. There's 2 8 microfarad capacitors, about 450 volts, as well as a was it one? I think it was 25 microfarads at 100 volts for the bias power supply, the ABC power supply. Rectifier here is either going to be an 80 or a 5Y3 depending on how old it is. 6C5 for the tone oscillator. And then on some versions, they actually use a part of the chassis down here for a electrolytic can, the aluminum style ones that you see later. You know, these multi-section electrolytics. This actually has an octal base, so not like that, but you get the idea. I think they move some things around on the top and on the bottom in order to accommodate that. This, however, is nice and easy because it means I can just cut the leads coming off the bottom of it. These straps holding it on are attached with what look like 632 hardware, so I can put in a terminal block, put the new caps in, and then just run the original wiring right to the terminal strip, save a bunch of time. As far as paper caps go on this side, there's one here across the AVC jacks. There's one trickily tucked up here against the that's not the band switch, that's the modulation select switch. That'll be a little interesting to get to, but this whole section here unscrews from the front panel, and we can sort of pull it out of the way to make it easier to get to that. Then there's also a few down under here, as well as some that need slightly more attention. Do my best to get this up there. Okay, so we have this 0.01, there is this 0.1 here, and then there's these two 0.01s tucked back here. These are important. These are actually part of the power supply filtering. The line cord comes in, and it actually goes through each side, line and hot and neutral, both go through RF chokes. I double-checked these. They're still good. The primary winding is still good. But there's one of these caps coming off of each side, and we're going to need to replace those with Y-type. In this case, got my Y-type 0.01s right here. Those will go in. Replace those two guys. I'll check some of the resistors in here. There are some resistors on this tube socket. That one's not quite as consequential because it's only producing a noise. It's not so much messing with the accuracy of the output. That is the concern of the other side here, where Precision's highly touted unit oscillator design that they came up with for the original E-200 is used. So this 6J7, SJ7 is just sort of sitting on its throne, and you have all the coils for the individual bands. It's worth mentioning, though, that the upper three bands in the megahertz, the F, F2, and F4, all share one tank circuit. So they're generating all those frequencies using one set, so I'm curious to see how that looks on my oscilloscope and what the accuracy is of that signal. There's only two capacitors on this we really need to concern ourselves with. This 0.01 right here, and I believe this guy right here, there's also a 0.01. There are some fixed micas on here. I'm going to leave them be, give them the benefit of the doubt. Not just because I'm low on some of my mica values, but also because this isn't a TV. They aren't being subjected to super high voltages, not like in the thousands of volts, so they're probably okay. Now, the RF output controls are actually shielded by this box. Actually, there's a lot of nice shielding in this set. And there is one paper cap hiding right here that is coupling the output from these guys, so that'll need to be replaced. All very clean. Oh, and the 4,000 ohm resistor that couples the low and high sides jack. It's hard to see, but there's a piece of black cambric tubing right here. As far as I can tell, that is where the resistor is living. They actually soldered one end of it to the jack, and then they sleeved it and hooked it up to the center tap there. So that's where that's going. One other nice little feature I noticed while I was taking it apart is that, unlike on most radios, the variable capacitor here actually has a piece of rubber wrapped around the top, so that if you accidentally go all the way and keep rotating, it rests against that instead of slamming into a piece of metal, which is a nice feature. Now, the knob does also slip, and I doubt that's an intended feature. I'm pretty sure that's just because the set screw is loose. I mean, there might be a bit of a clutch action there, but I don't know. Either way, that's what we're working with, and I think my plan of attack is going to be to get into the power supply section, make this safe first, then I'll deal with everything under here, and I want to verify that we have high voltage to the rectifier socket here to make sure that the plate supply is good. And then I'll probably pop the rectifier in, check that we have high voltage to the rest of it, see if we get anything out of it, and then work through the rest of the stages. Okay, really quickly here, because the battery on the camera is dying, I've got capacitors replaced, most of the paper caps. I haven't done the electrolytics yet, getting to that. Don't have it powered up all the way full line voltage, and I've got it on my Variac for safety. Right now we're on band E, which is covering 4.2 to about 12 megahertz. And I'm just checking to see if the oscillator is working. Scope I borrowed from work says yes, oscillator is working. And as far as frequency accuracy goes, it's not that bad. It's jittering a little bit, but I think that's because the controls in here are a little squirrely. They're probably still kind of nasty. But the dial currently is sitting on top of the 8 megahertz position, and according to the scope, we are getting 7.9567. So pretty close. If I twist this down and go back to the very bottom of the range to 4.2, yeah, it's trying to agree. It's having a little trouble. 4.45, if I'm sitting on the 4.5, I go up to 5 megahertz, maybe. Yeah, right about 5. 5.5. Yeah, about 5.5. Okay, great. Now if I go up to the last section, this is the one where I'm curious about the accuracy. This is F. So if I dial it into here, that's supposed to be 12 megahertz. We're getting 11.9. Okay. And again, I'm not cranked up all the way. I'm at 90 volts. Maybe coax a little more out of it. See if it makes it a little more accurate. I don't think it will. Yeah, we're still at about 11.9. Let's see, go up to 14. 13.8 maybe. Up to 18. Now it's not having as much fun. Let me hit auto setup here and see if it can capture it. Not quite. One thing that I do dislike about digital scopes is just looking at the waveforms. You see a lot of other junk because of how it's sampling. I like an analog scope because sometimes I just want to look at the waveform. But I also want to be able to see if the frequency is accurate. And I think this is telling me that yes, it is pretty accurate. So I set that to 10 megahertz. Yeah, it's a little squirrely, but it seems to be about right. It'll probably help that I replace the electrolytics. We might actually be getting some power supply hum into the plate of the oscillator tube there, so that's probably not helping. I'm going to go ahead and kill this, but what's interesting, so that's the modulation, and I can crank that up and we can see it on there, but I noticed this uses a transformer to couple the audio signal into the output, and I found that if I listen very closely, I can actually hear the 400 hertz tone being generated, probably coming out of the windings of that transformer. Very, very, very subtle, but I can hear it, which is kind of neat. But either way, oscillator is actually working. Still need to clean the controls, and I need to wrap up the last few capacitors in the power supply, and then see if it'll work. Probably break out a radio and see if it does what it should, and get rid of this junk right here. Okay, so I got the power supply rebuilt. All new electrolytics are in. I'll show you what that looks like in a minute here. But our output much cleaner looking. I still need to clean these controls because they're still a little... Let's see it, yeah. Still a little crusty in there, so it's not doing a whole heck of a lot for this. Dial reads 11 megahertz. Meter says about 10.8. We scale it back to 8 megahertz. We're at about 7.94. Let's try some of the lower frequency bands. I'll probably have to hit the auto range button. I'm on band D. D is down here apparently. So if I set that there, that's said should be 2.5. This is saying about 5, so I'm probably seeing a multiple of that. Let's try auto ranging it. Interesting. Try again. Alright, now it's saying about 2.5 megahertz, which is what we're sitting on. And it's not particularly stable. Of course, I haven't cleaned the band switch either. 2. It's flickering, but it's occasionally locking at about 2. Okay, let's try a different band. C is the standard broadcast band, so we would expect to see about 600 kilocycles or so in there. Or we would hope, right? Well, yes, we are seeing about 600, 599 and change. So, okay. The actual waveform, though... Oh, that's ugly. Let's try cranking it up and see if it gets any better. It doesn't look like it is. That's about 800. Meter says 800. Okay. That's 1.1. Yep. 1300, basically on the dot. 1500. But now we're reading multiples. We're seeing 3 megahertz on there. Reset this. Okay, 1.5. Wow, it's a hell of a roller coaster. But it... I guess I can speak to the accuracy. Yes, what's on the dial is matching up with the output. Let's see if we go down a band into the frequency range we would normally use for IF alignment. Let's try 455 and see how close we can get. There's 450. That right there should be 455. And I'm reading more along the lines of 470. Am I reading that wrong? That should be 450. That's reading about 10 kilohertz over at 460. This may be a case where I have to go through and slightly tweak each band so that it measures up right, because if that band doesn't measure up accurately, it doesn't do me any good. So for example, right... that should be 600. We're at 623. Let's go to the opposite end of the band. 220. Okay, well 220 is accurate. Let's try 250. 250 is accurate. 300. 300 is accurate, but we're starting to gain a little bit. 350. Okay. 400. Still a little over. 450. We're gaining a little more. I suppose as far as accuracy goes, that's about as good as you really do get. Let's see. Let's try the A band. What's that look like? Well, on the high end, the A band goes up to 250 kilocycles. We're at about 247. Sweep down to the other end, which is 90. And it's flickering, but I am seeing about 89 on there. Kind of. Wow, that is noisy. Oh, okay. There's only one or two more caps for me to actually replace. And that's over here in the ABC section. And then I do need to go through, clean the controls, and scrub down the wafer switches in the wafer switch in the actual oscillator section. I'm hoping that what I'm seeing here is a result of just dirty contacts. Okay, so I went in and I cleaned up a few of the controls. I got deoxit in both of the RF controls, and I also went through with a cotton swab and deoxit and cleaned all the wipers on this band switch. There's actually only two main segments and then the underside of that. Very simple, actually really easy to get into because of how far apart it's spaced. So that was nice. So I got that taken care of. The waveforms I'm getting on the different bands are cleaner, but because of how this generates some of the higher signals, it still looks like a garbled spaghetti mess on some of the higher bands. Right now I'm just testing the AM 500, and this one's set up for 550 to 1700, which I'll probably use quite a bit. Right now we're sitting at 800 on the dial, and we're reading about 800.4 on here. And I can confirm that if I rotate it down to about 550, we are getting 549, 550 and change. So that's cool. Now we get up to about 1,000, and we start seeing all the additional stuff coming in. If I set it to about 1100, 1.1 megahertz. Let's go up to 1300, 1.3 megahertz. 1500, 1.49, 1.5, very nice. And finally, 1700, 1.7 megahertz. So that band is very accurate. Excellent. Now let's go down one, because just underneath of the B band is where I'm going to be using for intermediate frequency setting. So 455 is what I usually use. So let's check 400. 407. This is the one where I noticed it was a few kilohertz higher than listed. So 450, for example, is actually reading 460. So what happens if we turn up the RF control all the way? Nope, still 460. All right. So that means 455 is just a little below that. Okay. That's probably close enough for this sort of work, honestly. Now, the one that I do want to check for is actually fairly low on here. The Atwater Kent that I'm going to be working on has an intermediate frequency of 175 kilohertz. So let's go down to band A, and let's see if this thing can lock onto a frequency that low. It can. Alright. Alright, where are we right now? We are sitting at 150 on the dial. We are at 149.9 kilohertz. Okay. Let's go up to 160, 159.3, 170, 170, okay. Let's just go up all the way to the upper end of the band, see if the bounds are about right. 246 on 250, so a little under. And if we run it all the way down, 90, okay. So, yeah, it's a little off in some spots, but overall not bad. Now, where's 175? Is it where it actually says it should be on the dial? Which I believe is here. That's 171. Let's see. This should be about 180, which it is. So 175 should be that pip. 174.4, alright. So that's pretty good. Let's check, let's say 100 and... What's 130? 129.4? Okay. Yeah, I would say this is pretty darn accurate, at least for the work that I'm going to be doing. Now, we can actually take a look at the upper bands. So let's switch over to F again. And as you can see, the wonderful signal we have here. Where am I on F? So F is actually these three, so I can get anything in there because of how it's generating that. Right now the counter is reading about 13.4, which is actually not too far off from where it's currently set, which I believe is 13.5. If I go down here, 12.9, okay. Scroll up a little bit, 18, 17.8, 22, 21.67, up to 26, 25.5. This may be one of those deals where, and it's interesting, you can see one of the main sinusoid in there on a couple of all the others. If I do this, and we get a closer look at it, okay. It's off by about half a megahertz. It's not horrible. And it seems to be off by about half a megahertz across. No, that one's pretty close. So it starts to get a little iffier the further up the dial I go. But ultimately, the frequencies that I'm interested in are going to be around here. The tricky part is going to be whether or not the peaking coils in the TVs I'm working on are okay with the generator making the higher frequencies in this manner. It probably will. But yeah, overall seems pretty stable. If I do modulated, no, I might have to get you a little closer to the scope. You can see here. Now I've got the modulation controller cranked all the way down, so if I engage the 400 Hertz test tone, I can actually hear that from here. You can see how the waveform sort of shrinks a little bit. Now if I turn the modulation control up, yeah. And 100% modulation looks a little something like that. Cool. Now if we were to modulate something on the AM band, let's go back to here. Auto range it again. Let's set this for 800 kilocycles. Crank up the modulation control. And I remember where I set it down. Where did I set it down? Ah, here we are. I've got a knockoff Philco transistor radio. Let's see if we can hear it. I'm going to wrap this wire and the antenna around here, see if we can't get it to couple through. On AM. Oop. Okay, yes. We're going to 700 and see if we can pick it up there. Huh. Interesting. I seem to be picking up everything. Oh, wait a minute. I think that's it right there. Yeah, there it is. Okay, so yes, it does work. Very cool. So I think that's going to about do it for the electrical side of things. I'll flip it around and show you how I did the electrolytics, as I totally missed out on that, as well as my solution to getting to some of the capacitors that were tucked back here, because I wasn't able to do it the way I really wanted to. So let me get the scope out of the way, and then we'll get this turned off. As far as the aesthetics go, I was cleaning it up, and I already took apart the plastic needle here. I used Nova's plastic polish and cleaned both sides, got quite a bit of residue off of it. I will say, the lower half of it is held on with screws and nuts on the back. On the top one, these are apparently threaded. The bottoms may have been threaded at some point, and the threads may have stripped out, and they had to put nuts and washers in there to hold it. But there's a lot of tiny, tiny washers in there that hold this far enough away from the plate so that it doesn't drag. And they tend to go everywhere, so trying to stack them back up like Jenga blocks to get them back in place was a bit tricky. Don't use magnetic screwdrivers if you're trying to tap them into place. I did manage to get deoxit into these, so that was pretty nice. I haven't done the modulation control, but I don't know if I need to necessarily. Oh, right, aesthetics. So when I looked at this, I wasn't sure if the sort of dull gray appearance of most of the silk screening, well, in this case it's actually engraved, it's not silk screen, it's not a flat surface, there's actually grooves etched in there that are filled with paint. I wasn't sure if they were supposed to be dull like this or not, so I took a little bit of metal polishing compound to the edges and wound up shining it up, and I thought, oh, wow, that looks pretty nice. So I started going across and doing it to more of it, and then I did the band switch area. And now it's all nice and shiny. The problem is, I have no idea if these are supposed to be shiny or not, or if it was supposed to be like this. Most of it's still pretty grungy. But the polishing also made the paint in some areas look pretty nice, took off some of the crud that was caked on it. And now I don't know. I don't know if I want to keep polishing it because I'm not sure if that's factory or not. I mean, I own this, so I don't feel bad if I leave it, you know, half polished mirror finish and the rest of it is dull gray. But it's just, I haven't seen any other photos of these. I have other pieces of test equipment that have, most of my RCA stuff as a matter of fact, have really nice polished aluminum front panels. So I'm not sure if that's originally how this was done, because this stuff cleaned off pretty easily and I wasn't sure if it was a coating or not. So that's, I think that's more of a down to personal taste at this point, and I don't want to have to take all the controls off of it. I'm kind of just cleaning around them as I go. So I'm probably going to just wind up directly using this, like right out of the gate to do what I need to do, and maybe I'll clean it up over time. That being said, as far as the electrolytics go, the original can, this big guy right here, got that pulled out. Like I said earlier, two 8 microfarad at 450 volts and 125 microfarad at 100 volts. I replaced those with some 10s, so that's 110 here, 110 there. This guy in the middle, that's actually 33 microfarads at 160 volts. That was the closest standard value I had for that cap. And I set them up in a simple block. Now, I'm using new wire because the originals actually were not long enough to reach the terminal strip. So I undid them and I ran them through the bottom and I hooked them up exactly the way they were. I even passed them through the original loom to get them in the right spots and match the same colors. So the only other things I had to do then were replace this capacitor here, which is on the AVC output jacks. I haven't actually checked to see what the voltage from that is. I should probably do that. And then this pesky booger on the modulation switch down here, that thing, I was hoping originally to just unscrew this assembly and move it out of the way. What I didn't realize is that two of the screws that hold this center section on are behind the dial. And the only way to remove the dial is to undo a coupler between the tuning condenser and the dial itself, and taking the plastic back off, and I just cleaned it, so I decided, you know what, there's got to be I have small hands, and I have dental tools, so I went in there, I carefully extracted the original, cut the original leads off. Mercifully, whoever put the capacitors in this, the factory, did not bend the leads over the tabs, so they just fished them through the hole, soldered it, and then left it. I did the same thing putting it in. It didn't mean I had to get in there very carefully with my solder sucker to clean the terminals out. I suppose you could try pigtailing in here, but it's very cramped. And getting in through the bottom to access the connection on this terminal jack right here meant I had to go around this wire and kind of move it out of the... It was tricky. But I got it done. And yeah, that worked out pretty well. And I don't think I'll have to fiddle with anything in the oscillator section. It seems to be running just fine, accurate enough for my taste. The only other thing I will have to do, though, is deal with the power cord. And I keep a whole bunch of power cords pulled off of old equipment, because you never know when you just need the actual cord. I am not going to be saving this plug for two reasons. Number one, the original is supposed to be fused, and I did not put in a standalone fuse in this unit, so I'm going to go back on eBay, get myself another one of these. The other reason is the hole in the back side of the box isn't actually large enough to fit the whole plug through. It's not supposed to be. And I didn't think about that before I put this one on there, so my only other option would be to unsolder this and then reattach it. I'll probably just do that anyway because it was pretty easy to do. And I also need to put a knot, usually just a granny knot, in the end of the cord on the inside there to keep the cord from being yanked off of the chassis. So I'm just going to go like this, flipping over here, and just sort of work this back. I try to do this on all my radios and test equipment, even if they didn't have a knot on there. When it passes through the chassis, sometimes it's through a grommet, sometimes it isn't. I don't want someone to like move it away from a wall or something, or grab a hold of the cord by accident and yank on it. And if it's attached to something delicate like a power switch, it might rip the whole switch off the back of the control. You never know. Some of them are only held on with tabs. You don't know what you could break, or if it's if it's still plugged in and you start yanking on the cord at the back of the set, you rip it off and cause a short. All sorts of stupid things can happen. This is just cheap insurance. And having now done that, I have to undo it because I can't just pass this through the back of that. So that was a genius move. So thanks for coming to my demonstration. Let me just reverse what I did. All right. So yeah, on the whole, not very hard. The resistors that I checked were all still in spec. The big 9,000 ohm 10 watt guy here, all the little resistors in that. I didn't actually go in and check the resistors on the unit oscillator though. Because it's operating at the right points, I'm not going to mess with it. And not to mention, they are pretty deep into this assembly. And I don't feel like trying to dig some of these out, like that one right there that is bridging two sections of the wafer, or its buddy over here on the other side. Yeah. I think I'll leave well enough alone. It's working. That is all I can ask for. So one last thing before I get it back in its box, let's take a look at the automatic volume control power supply. Curious to see what it is capable of. So I wasn't entirely sure if the numbers on the panel here were actually directly related to voltage. And it is possible that it is. The numbers on the higher side of the scale do appear to correspond more appropriately with an output. So that's interesting. 40, 45, yeah, maximum about 46.7 volts. Interesting. I honestly don't know where I would ever see an automatic volume control circuit that would have that high of a generated voltage. I think I've seen the AVC bus in one set I worked on go as low as negative 20 volts. But 40? Dunno. Guess it depends on how it was built. Now, I might not be getting very good accuracy in the low end of things because this is, you know, dirty. So it might be a little more accurate if I clean that up. But again, I don't really know when I'm going to use that. So I think that's going to about do it for the repair work on the E-200-C. In the next video, I'm going to take it for a test drive and see if I can't utilize it to get the Atwater Kent that I'm working on to align correctly. Now, I'm not entirely sure that having a different generator there is going to make it work better, but I'm hoping it will, and maybe I can do a little bit of troubleshooting now that I know this is actually fairly well accurate. So, yeah, the only other thing it needs actually is a cable. I don't have any coax on me right now. I'm going to have to go to work and borrow some. I do, however, have a set of test leads made up with one of these Switchcraft mic jacks that I have on my B&K 1076, so I'll just borrow that one. And that should work a-okay for injecting a signal into the set. But yeah, I'm happy with how this came out. It's a neat little unit. And I'm used to using my RCA portable set for this. This guy, actually. Is this my WR50B? I normally use this for everything. But I've always felt that, you know, I don't know how accurate it is. It seemed pretty accurate the last time I put it on a scope and looked at it. But I don't know. I have more of that because I'm an RCA fanboy than anything. So we're going to give this guy a try and see if it can do better. And more importantly, this has a greater frequency range than this one does. This one does go up to 40 megacycles, which I'm just now realizing. But this one has a lot more features, and plus, I think from an aesthetic point of view, it looks cooler on the bench than that one does. But thanks again for sticking around, and I'll see you in the next one.